In the last module, we created a series of object mother classes to create canned objects for our tests. While an object mother can create well-known or randomly generated entities, it's not very flexible. Many times when writing tests, you need an object that's almost like the canned instance, but with one or two key differences, such as when you're testing boundary conditions for validation. Now let's look at turning our mother classes into a more flexible alternative known as a builder. A builder is a lot like an object mother, but with a Fluent interface tacked on to make it easy to manipulate the target object's properties. One major difference is that rather than returning the target object, the factory methods on a builder return a reference to the builder itself, allowing you to chain together multiple calls in one continuous expressive statement. Let's take a moment to define what a Fluent interface is. You see them all the time, but you may not always notice them because they've become such a part of daily developer life. They work by chaining together calls to the same or multiple different classes, so that you end up with code that reads like an ordinary English sentence, or as close to one as is possible given the subject matter. The above code reads quite well to a developer, but maybe not so much to the general public. They're built this way to aid in discoverability by the developers using the system. For instance, when building a LINQ query like this one, I can't call the thenInclude method without first calling include, and I can't call thenBy without first calling some form of order by. At each step, only valid choices are presented because the only methods you can possibly call are those that are exposed by the type returned by the previous method in the chain. Our Fluent interface won't be nearly that complicated, but it will provide the ability to build up a plan a piece at a time, describing the object we need for our test context. It will do this through a series of methods that each set an individual property and return a reference to the builder. When you're done describing the object, you call the build method, and it returns the object you've described. Let's start at the bottom of the object hierarchy, which is currently the country mother class, and rewrite it as a country builder. Let's create a new folder for our builders, and a class called country builder. The first step is to create an internal field to hold the object being constructed. Now we'll start building up the Fluent interface by adding a series of with methods. Each with method sets a single property on the backing object and once again returns a reference to the builder itself. Here we have with abbreviation, which takes a string value for the abbreviation property. I'll add the with methods for the name, description, postal code label, and state label fields as well. And finally, we'll need a method that tells the builder to return the object we've been describing. This is typically called build. This is the simplest possible implementation of a builder, so before we complicate things any further, let's take a look at what it looks like in use. I'll update the country repository tests to use the builder instead of the mother. You can see how the with methods chain together to describe the object we want in a readable way. That's fine, but all we have so far is a wordier way to new up an object, just like our tests were doing originally. The builder and its with methods form the basic building blocks we need to describe an object, but we still have to fully describe each object separately. We'll fix this by creating static factory methods that represent predefined starting points for the builder. These factory methods will let us share common object definitions across a wide variety of tests, and when they're not an exact fit, we can always use the with methods to do some last-minute fine-tuning to get just what we need for a specific context before finally calling the build method. Once we have some predefined builders in place, we'll almost never start from an empty builder again. The objects returned from these factory methods will become well known and are the ones we'll use most in our tests, because they'll allow us to focus our test contexts on just the interesting parts of the object graph and leave out the details that are unimportant to the test at hand. It's a lot like what we built with the object mothers, only now the modifications are done before we ever get a reference to the finished object, which has some advantages that we'll get to later on. Let's add some factory methods, which will borrow most of their code from CountryMother. We'll start with a new one called default. This does nothing more than return a new country builder without making any changes to it. All of its properties are set to their default starting values, so it's a pretty simple method. This has the same effect as simply constructing a new country builder yourself. But using the factory method will make its syntax more consistent with other variations when you really do want to start from scratch. Next is simple, and just like it did in the CountryMother class, it returns the bare minimum country that will pass validation and can be saved to the database. In this case, that means filling in the abbreviation and name properties. Typical will further build on simple and fill in any other property values we'd expect to find on a normal instance of the country class. These are optional parameters, but shouldn't represent anything out of the ordinary. The idea here is to follow the principle of least surprise and hand back a very ordinary instance of the target object that should behave in a very ordinary way. You can see how each factory method builds on top of the one that came before it. When you need a new special case, you can start from a case you already have in stock, tweak just a few properties, and return the new builder. If I were to add a new required property to country, I'd only need to fill it in the simple method, and all of the other factory methods built on top of it would inherit that value. If I added some new optional property, I'd assign a value in the typical method, or maybe even in a new layer on top of that if it's an uncommon property. The choices are endless and up to you. Now let's replace the calls to CountryMother with calls to CountryBuilder. Because we factored this out to an object mother in the last module, there should only be a couple of places to fix. With those changes out of the way, all of our tests should still pass, just as they did when we were using the CountryMother. Our new CountryBuilder class can now completely replace the older CountryMother class. Notice that with the CountryMother, we start off with a fully instantiated object and then make incremental changes to it. But with the CountryBuilder, we describe and retrieve the target object in one continuous chain of statements. We don't get a reference to the target object until the very end. Let's do one more by turning the StateMother into a StateBuilder. We'll go to the Builders folder and add a new StateBuilder class. We'll start with a basic shell, a backing field to hold the object under construction, a build method to return it, and with methods for each property of the target object. In the case of state, that's with abbreviation, with name, and with description, just like CountryBuilder had. States also have a country property though, so let's add a with country as well. It takes in a country, assigns it to the country property on the backing variable, and returns a reference to the builder, just like the other with methods. Since we've been given an entire country object, we can go ahead and set the country ID property as well. While we're here, let's take the opportunity to add another method for with country ID to let us set the ID when we don't have or need the full object. It'll do exactly the opposite by setting the ID and clearing the country object reference. Next, we'll add in our factory methods, starting with default, which is the easiest. We'll follow that up with simple and fill in the required properties. In the case of state, that's abbreviation, name, and country. We have a choice here. We can either create a new country for each state by calling CountryBuilder.simple, Or we could just fill in a known, valid country ID. We won't typically be inventing new countries as part of day-to-day business, but these tests run against a throwaway database, so it doesn't hurt us any to make up new countries on the fly during the tests. If country were a particularly expensive object to create, then we might want to just fill in the country ID here instead. That's entirely up to you and can change from test to test. Either way, the State Builder leverages the Country Builder, just as State Mother used Country Mother. Let's finish up the factory methods by adding in our typical method, which takes the output of simple and fills in the optional description property. But where should I put the parent-child relationship fix-up code from State Mother? Here in the build method seems like a pretty good place, so I'll take that code that used to live in State Mother and move it here. When I call the build method, the State Builder will establish the relationships between the state and its country by adding the state to the country's states collection. Since there's a possibility that someone could set country to null as part of a test, let's make sure that the build method won't blow up and throw null reference exceptions by using the null propagating operator. You can continue adding any additional factory methods you need for your tests. It's encouraged. The whole point of factoring out the test object creation is so that future tests can directly benefit from what you've already built. You can even start at a fully populated builder like typical, and then take things away if that's easier than building up. We can even add convenience methods for those changes. For instance, I could add a without country method that simply clears the country and country ID properties on the backing object. This is great so far, but you'll notice that any time one of our factory methods uses the builders below it, it calls the build method right away. While our top-level builder hasn't yet been executed, its children have. So even though we might say we don't want a country by using the without country method, one was already created back in the simple method. We just threw it away afterwards. Normally this shouldn't be a problem, but it could potentially have an impact on our test suite's speed if it's used to build up unusually large hierarchies of objects, and then we simply throw parts of them away. Ideally, a builder should be a plan or blueprint for the object that we want, rather than just a wrapper for the object itself. We're looking for a way to describe the object rather than build it right away. Only when we're finished with the explanation do we want to build the final object graph. We want a hierarchy of builders that won't execute until we call the build method on the root builder. This way we can continue to alter the plan right up until we build the whole thing.